common misconception of black holes is that stellar black holes formed from a star, are the only means of forming a black hole. This is certainly not the case, but is the most common way. Now, a star that has enough mass that collapses into a black hole is, to our knowledge, the only natural phenomenon where a black hole is created. But this isn't the only way to create a black hole. Although we can't do them ourselves, there are basically two ways of forming a black hole. Either compress a fixed amount of matter until it becomes small and dense enough to become a black hole, or keep on adding mass to an object until it's so big that it becomes a black hole. Compressing a fixed amount of matter until it becomes a black hole has to do with something called the Schwarzschild radius. The Schwarzschild radius is the radius of a sphere that if the mass of an object were to be compressed within that sphere, it would collapse into a black hole. Each object has its own unique Schwarzschild radius, as it varies depending only on the mass of the given object. We can calculate the Schwarzschild radius of an object using this equation, where Rs is the Schwarzschild radius, g is the gravitational constant, m is the mass of the object, and c is the speed of light. G and c squared are just constant, so the only thing that is changing is the mass of the object, so the Schwarzschild radius depends only on the mass of the object. The larger the mass of the black hole, the bigger the Schwarzschild radius. They're directly proportional, so if you double the mass, you double the Schwarzschild radius. Another common misconception of black holes is the confusion between the Schwarzschild radius and the event horizon. As mentioned previously, the Schwarzschild radius is the radius of a sphere that if the mass of an object were to be compressed within that sphere, it would collapse into a black hole. Whereas the event horizon is the imaginary boundary of a black hole beyond which nothing can escape, not even light, the fastest thing in the universe. So the event horizon is almost like the outline of a black hole. Using this equation, we can calculate the Schwarzschild radii of some other objects. The Schwarzschild radius of the Sun is about 3 kilometers. The Schwarzschild radius of Earth is about 1 centimeter. Now, while these are good examples of the sheer small size it is compared to its original size, the Schwarzschild radius of Jupiter, which is about 2 meters, gives you a really good idea of how small and dense it really needs to be. The other way of forming a black hole is to keep on adding mass to an existing object until it's so big that it becomes a black hole. This only works because as you increase the mass, the Schwarzschild radius also increases, but the radius of the object doesn't increase as much as the Schwarzschild radius. So at a certain point, the Schwarzschild radius eventually catches up with the radius of the object. Therefore, if we keep adding matter to the Earth, then eventually it will reach its own Schwarzschild radius, collapsing into a black hole. I need to give credit to Minute Physics. Some of the numbers and ideas in this video are from his video. I'll never do a similar video to someone else's like this again, I just wanted to share this with you. I recommend watching that video from Minute Physics, who did a video on this topic as well. He takes a closer look on the maths involved also. Comment down below your thoughts on the Schwarzschild radius. Make sure you subscribe for more content on astronomy and futurism. If you enjoyed this video, check out my most recent video or again this video from Minute Physics. Thank you so much for watching, have a nice day.